So our this section is actually 18 mark section, if I'm not wrong. It has electromagnetic waves, it has wave optics, it has got ray optics. Ray optics, wave optics is more or less like theory for you. Electromagnetic waves will also be theory for you. Here you might have, not you might, you will have a lot of numericals out here. Okay, and let's get into our basic concepts once again and start with light and its dual nature. So light travels in a straight line, we know about it, and light also is a wave. Okay, because if you have studied wave optics, then we will know that a part of the electromagnetic spectrum, that is completely a wave, and there 400 to 700 nanometers is what is light. So what is the difference first between wave optics and ray optics? Okay, now if you see light, it is characterized by three things. One is obviously the wavelength. Okay, in terms of wave model, it has a wavelength and it will also have a speed. The speed of light is denoted by c, roughly taken as 3 into 10 to the power 8 meters per second, and the wavelength is denoted by lambda. So 400 to 700 nanometers is light, which is the visible portion of the spectrum. Now if you take objects, daily objects, okay, daily objects. Now daily objects is actually a selling site. Okay, daily objects, and say you see their sizes, their sizes, if you compare it with this wavelength, then they are very large. You mean to say, look at the table, right? The table size will be in some meters, whereas if you look at the wavelength, it is in nanometers. For such size objects, light travels in a straight line. You won't see any of the wave nature like bending around the corners or things like diffraction. Those phenomena we won't see in the case of light when we are dealing with daily objects. And light travels in a straight line. So that branch of optics, optics means light, that branch of optics, which is actually studying with all phenomena associated with light, when you are studying objects which are sizes are very large as compared to parameters of light, that branch will be known as ray optics, and here light will be traveling in a straight line. And the branch where object sizes are comparable to the parameters of light, means the wavelength is small, the size of that slit will be also very small. Those we will study under wave optics, because their light will be going as a wave. Is this much clear? Right? So we now get into our studies all into ray optics, and we will be studying reflection, refraction. So we start with reflection, and obviously this reflection will be all about spherical mirrors. Right? Initial stages are not that tough. Shall we go ahead? Okay. So our discussion starts with spherical mirrors, and we will go with our basics. Okay. So the topic is about spherical mirrors. Okay. In order to understand spherical mirrors, we need to first understand a hollow glass sphere. This is something that you need to conceptualize. What is a hollow glass sphere? Something like that globe. It is all of glass. So it's like it's a hollow glass sphere. That means although I have drawn a 2D object, this is to be taken as a sphere. This is to be taken as a sphere, and I call it a hollow glass sphere. A hollow glass sphere is a 3D object which is a sphere, and obviously it must be having its center. Take a portion of that hollow glass sphere and you just slice it through. All right, what you will be getting is something like a ball. You'll be getting something like a ball, or a petri dish, as we say in biolab, something which is like a like the dish antennas, dish kept in front of you. Are you understanding? So let's say this section is say AB, and let's say this section is CD. Okay. Now AB is a section we would see like this. This is the section AB. Now children think that this is a portion of a broken bangle. No, this is not a portion of a broken bangle. It is actually think about the umbrella which you have just opened up, and is the umbrella's entire fabric portion in the manner. Now if we actually make the rough surface on the outer side, right, and have the shiny surface on the inner side, we use the word shiny, we use the word polished, or we use the word smooth side. So this is my rough side, and this is my smooth side. Okay, this is my smooth side. I form what is known as a concave mirror, and the best way to understand is, as I used to say, take a child and make the child sit inside this mirror. If the mirror is caving on the child, it's a concave mirror, right? Doesn't mean that the orientation has to be like this. We can also have the orientation in this way, and we know our child has to sit in this side, the mirror, so the rough surface has to be on this side. This is a concave mirror. Understood? Okay. Similarly, we can also make what is known as a convex mirror. The convex mirror will be in such a manner that the inner side will be rough now and the outer side will be polished. So this is my convex mirror, and this is concave. And you can make it in this orientation also. In this case, we will etch this side. Fine. No issues, children. Concave and convex. And as usual, whenever we study mirrors, we study concave more. Whenever we study lens, we study convex more. Okay. So in lens, mirrors, we will be studying more and more of concave. Understood? Okay. And the center of that hollow sphere, from where you have cut out this portion, that is the C is known as your center of curvature of the mirror. Center of curvature. And the radius of that hollow sphere R will be known as your radius of curvature. This is your radius of curvature. The mirror will also have a central position. Now, to understand it, central position means as you open the umbrella, there is going to be a portion in the fabric to which the rod of the umbrella is going to protrude outwards. That point. Understood? From where the J stick, umbrella is like a J stick, the rod protrudes outwards. That is known as the center of the umbrella, and we would call it P, standing for the pole. P. And this is your P. Clear? Can I go to next slide? If you are fine till now, no confusions. Okay, so let's go to the next slide. So we now have our concave mirror. Why do you, sir, always draw it in this manner? Because the study of ray optics is such that the incident light is always taken to be traveling from left to right. That's the reason why I draw it in this manner. I could have drawn it in the other manner also. Okay. Now, when we talk about ray optics and ray shows the path of travel of light. And to understand all the phenomenon of image formation, magnification, etc., we conceptualize this geometry. There is nothing called rays in actual. These are all some sort of imaginary things. Kalpanik hai. We conceptualize in order to support our understanding. So that we give an angle of geometry to it. Obviously now I have got pole out here, and I have also got the center of curvature. So I create an imaginary line which will be passing through the pole as well as the center of curvature, and this imaginary line will be known as my principal axis. Principal, P-R-I-N-C-I-P-A-L, principal axis. Fine. This is known as my principal axis. So I now know what is my center of curvature. I also know what is my radius of curvature. I know what is principal axis. I know the pole. Now is the time to define what is known as the principal focus. And we are going to define the principal focus for what? Concave mirror. Concave mirror. Now, in order to understand the principal focus, we take something which is known as para-axial rays, or rays which are parallel to the principal axis. Okay, let me do one thing. Before going to the principal focus, let's also dive into what is called the laws of reflection. Laws of reflection. The laws of reflection states, because we have done this in grade 9, the angle of incidence will be always equal to the angle of reflection, and the incident ray, the normal at point of incidence, and the reflected ray, okay, reflected ray, all lie on the same plane, all lie on same plane. And your understanding about it so much, till so many days, was all about plane mirrors, where we used to show this. So to understand this in easy language, let's say, do you understand all lie on the same plane? Are you familiar with that? All lie on the same plane. It means the incident ray, the reflected ray, and the normal are coplanar. How to understand coplanar? You can take a textbook and fix behind them. They're not like the tripod stand, 3 in 3 different orientation. You can take the 3 arrows. So the incident rays might actually come in this plane, might come oblique plane. It's like this. The incident ray would be, this is a plane, and this plane would, this is my reflective surface. So it can be reflecting 90 degree, this angle, whatever. Means if this is the incident ray, the reflected ray lies on this plane, and then normal also lies on the same plane. Is that clear? Now, when we try to see this in terms of, what you call spherical mirror, that is either a convex or a concave, then we start thinking, now the mirror is no more straight. So how do we treat the laws of reflection? Well, these are laws. A law is always valid. So how do we treat it now? Say this is an incident ray, okay? This is an incident ray, and it is incident on a particular point. At that point, the first thing what I will do is that I will draw the tangent at that point. So I will be drawing tangent at that point. 1 minute. So this is the tangent at this point, correct? Now I will draw the normal to the tangent. This, and then I will be making my reflected ray. And so I say that if this is my angle of incidence, this is my angle of reflection. Is the concept clear? Laws of reflection holds true even in spherical mirrors. Only thing is that at that point, the normal is drawn in what manner? It's a part of a circle. So the circle will always have a tangent, and the tangent will always have, every tangent will always have a normal, and this normal should pass through the center of curvature. Go back to grade 9. Whenever we draw a tangent, radius to the tangent or radius to the point of contact is always perpendicular to the tangent. Is this much clear? Okay, so okay, so this is there, right? So we go ahead and now get into defining what is called as the principal focus. Principal focus. So This is my center of curvature, and this is my pole. In order to understand principal focus, we take para-axial rays, rays which are parallel and very close to the principal axis. Parallel and very close to the principal axis. Parallel and close to the principal axis. After reflection, will converge, on one point, and this point is called your focus. So principal focus of a concave mirror. Get the facts correct. Nobody will ask you his definition. The principal focus of a concave mirror is a point on the principal axis at which para-axial rays parallel to the principal axis converge upon after getting reflected from the concave mirror. They converge upon, and that's one of the reasons that this mirror is also called a converging mirror. This is the first difference between plane mirrors and spherical mirrors. Spherical mirrors have got the capacity to converge rays, or they can also diverge rays. Whereas in case of straight mirrors, you don't see that convergence or divergence. So what is the principal focus? The principal focus of a concave mirror is a point on the principal axis at which para-axial rays parallel to the principal axis converge upon after getting reflected from the concave mirror. Is understood? Okay. Few things which you should know now as senior students are: number one, you have rays. Now this is a conceptual thing. First, let's understand the concept. Okay, so when we are understanding concept, we will create one line, and so that we divide the board. Hang on. So let's do some conceptual thing. Okay. So I have a ray. This ray is a incident ray. All right. And this incident ray undergoes a reflection. In the case of lenses, it will be refraction. So it is not one ray. I have another ray or many collection of rays which are incident ray. They undergoes reflection and then they meet, or I use the word intersect, at a point. Okay, they intersect as a point. Whenever they meet or intersect as a point, such a point will be known as a real point. It will be known as a real point. So if you look at this focus, the two reflected rays have actually intersected at this place. That's why the principal focus of a concave mirror will be known as a real focus. Is this clear? It is known as a real focus. Also, if you revisit grade 10, okay, let's see a little bit of grade 10 also out here. Say I have a concave mirror and this is my pole, this is my focus, this is my center of curvature, and say suppose I have kept an object between pole and center of curvature. You remember, right? Concave mirror will always create everything inverted except dentist lipstick. Remember that. Except when you are using it as a dentist mirror or as a vanity mirror. You remember dentist lipstick, I used to say. So ray of light which originates from here, say it's originating from here, it's parallel to the focus, it passes through the focus. Okay. And similarly, if this was bigger, then what I try to say is that, let's say there is another ray of light which is incident at the pole, right? And this will come somewhere here. So we get our image somewhere at this spot. What we try to emphasize out here is not the image formation rule. What I'm trying to emphasize out here is from a point where the rays originate till the point where the rays meet. So if you see an image is actually a path transformation of the object itself, right? And such sort of image will be known as a real image. We will see those. And if this image would have formed not by intersecting rays, but the rays were actually divergent, and we pulled them back to see from where they originated, that sort of an image will be known as a virtual image. So we continue this part of our what you call discussion, and I say if the rays meet and intersect, this can be option one. If the rays diverge, if the rays diverge, then we pull them backwards, pull backwards, okay, to find point from where they originated, and such a point we will call as a virtual point. Means actual intersection of rays did not take place at that point at all. That point has been found by extrapolating the rays which are divergent now in nature. Divergent rays are never going to meet in the long course, so we call them as virtual point. So if you look at the focus of a concave mirror, the focus of a concave mirror is real. And on the same side, if I take a convex mirror, let's say this is my convex mirror. So similarly, I would have a P. The center of curvature now is, children, behind the mirror. The center of curvature was in front of the mirror. Now the center of curvature goes behind the mirror. So what we will take, we will again take paraxial rays, rays which are parallel and close to the principal axis. So these are my paraxial rays. Now, pardon me, allow me to first, so that to keep the drawings, to keep the drawing correct, but that is not the way you are supposed to do. So this is one, and this is one. Sorry. I'm making it so that the drawing looks correct. So this ray is going to come and hit the concave surface, convex surface, and it will actually, sorry, diverge out in this manner. And similarly, the ray which was below the principal axis will actually diverge. See, this is the actual happening. The ray comes in this manner and goes out. This ray has come in this manner, has gone out. They are known as divergent rays. Are they going to meet ever? No, they're not going to meet ever. So we are now interested to pull them backwards. That's where I pull them backwards. Although I did this job first, just to make sure that the drawing looks perfect. And I get a focus now. Now this point of intersection will be my focus. So what is the focus of a convex mirror? This is a convex mirror. So I would write the principal focus. The principal focus of a convex mirror is a point on the principal axis from which paraxial rays parallel to the principal axis appear to diverge after getting reflected from the convex mirror. Appear to diverge. Since this point has been created or has been formed by the extrapolation of rays, we will say that this focus is a virtual focus. Now these can come as 1 mark question. The focus of a convex mirror is a virtual focus. Focus lies behind the what you call the mirror, and the distance between focus and pole will be known as the distance. The distance between focus and pole is known as focal length, usually denoted by the small letter f, the focal length. So in our diagram, This is my focal length. ठीक है? Can I change this? Okay. We'll see one more criteria for concave. As I said, our study is more about concave, concave, concave. So this is my concave mirror. Okay. And this is the principal axis, right? So say this is my center of curvature. This is my principal focus. This is my pole. Now what I do, through my focus, I have created one axis, okay? And I create what is known as a plane out here. Are you able to understand what is this thing? Now you have the umbrella open right in front of you, that is the J stick, and between the umbrella's pole point and the J portion, you have actually put one A4 paper, and the A4 paper is put perpendicular to that principal axis right at the focus. Such plane, so it creates a plane. That plane will be known as my focal plane. So this will be known as my focal plane. And what is the beauty of this focal plane? So let's say we take again para-axial rays, but the rays this time are not parallel to the principal axis. The rays are not parallel to the principal axis. So these are my para-axial rays. Now these rays are not going to converge right at the focus, but they will be definitely, it will not meet at the focus was that point on the J stick, but it will meet somewhere on that focal plane itself. So we will see that they will actually converge on the focal plane. I am drawing it here. It could have been here also because the plane extends infinitely. And rays coming from a distant, far off objects are always taken to be parallel. So this is the beauty of focal plane. Have you understood? Okay. Now, revisiting some of the rules for image formation. 4 rules for image formation, and this is very specific. You are doing this for concave mirror. So the rules are 4 rules, and I'm writing them in short. A ray which is parallel to the principal axis will always pass through, this is the symbol for pass through focus after reflection. The second one is just the opposite of this. So I say the ray through focus after reflection becomes parallel to principal axis. Again, number 3, ray through center of curvature is reflected on the same path. Is reflected back on the same path. So no deviation. What I mean to say is, suppose there was a ray which was going from the center of curvature, means just see this children once, from the center of curvature I have taken a ray. This ray will get reflected along the same path, means it will again come back along the same path. This. Okay? And the fourth is, at pole, the angle of incidence is equal to angle of reflection. It is actually always like that. It's not about at pole. Angle of incidence is equal to angle of reflection. This is a truth. But here we will say the angle of incidence is nothing but angle between, now children try to see this, between incident ray and principal axis. See, at pole, what is the beauty at pole? Look here, at pole, this is my radius, this is the point of contact, right? So my tangent will be actually perpendicular to the radius. Do you agree or not? So any ray which is incident out here at the pole, for that ray, the principal axis itself is the normal. So we say that the angle between the incident ray and the principal axis will be equal to angle between reflected ray and principal axis. This holds only in the case of, only in the case of pole. So the story is something like this. This angle will be same as, and I'm sorry, figure has got too much mutated. So let's say this becomes my angle of incidence, and this becomes my angle of reflection. These are the 4 laws that we use. You fine till here? Okay. And then we need to practice problems related to all grade 10 problems itself. Going ahead. My next topic would be to give you a recap, because this we will be using sine. You want me to go back? Yeah, sure. 4 laws. At the pole, this angle will be equal to this. This is the actually law of reflection itself, where the principal axis as a special case is behaving like the normal also. Shall I go ahead? So my next thing would be sign conventions. Sign conventions, and this sign convention shall hold whether you are doing convex or concave. So what I do, I will be creating my Cartesian coordinate system. So, and I'll explain this with the help of concave mirror only, so that it becomes easy for us to understand. Okay. As usual, x dash is negative, y is positive, y dash is negative. All distances are measured from the origin. So all distances will be measured from origin, right? So sign conventions, but before that, some of the what you call protocols that we follow. The incident ray is always taken to travel from left hand side to right hand side. Means from left hand side to right hand side, right? Now all distances would be measured in this side. So let's just see. So let's say I keep an object out here. This is my object, right? And let's say this is center of curvature, this is focus, and this is pole, right? So how do I get an image of this? A ray parallel to the principal axis will pass through the focus. So let it pass through the focus. It passes through the focus, and a ray which goes through the an array which goes through the center of curvature goes undeflected, right? So it will go undeflected, which means this ray is going to pass out on the same side like this. Fine. So I get my image at this position, and while you are actually getting your image, you should see that the head rays now came in this manner. So this is now my new head. So if my object was AB, my image is A dash, B dash. Clear? What will you call this image, children? I'll call this image as a real image, because real, and an inverted image, because this image has been formed by actual intersection of rays. Come on. So let's see some what you call namings. So here, then, okay, so let's say and this. Of late, derivations and all have been reduced a lot. Okay, now some of the things. The focal length is represented as f. Okay, the image distance is represented with the word v, vip, as I used to say, vip, v for v and I for image, and the object distance is denoted by small u. And we used to say, when are we doing this for a concave mirror, all distances are measured from where? All distances are measured from the origin. Now from the origin you are going to measure the focal length. From origin I am measuring. Which side I am going? I am going on the negative x-axis. So the focal length will be in numerical problems taken with a negative. That is for a concave mirror. But remember, for a convex mirror, the focal length was on this side, so the measurement will be in positive, right? So this will become my negative v, and this will become my negative u. Similarly, if I take the height of the object as h and the height of the object image as h dash or hi, let's, for easiness, let's take this as ho. Ho is heading upwards. From the origin, you are measuring HO upwards, right? So HO would be positive, whereas my HI in this case would be negative because I'm measuring it down. Arjun, clear so far? No issues? Okay. Fine. Can I go to the next slide? Okay, the next one. The next one is your establishment of first formula, where we say that the radius of curvature, which is r, is half, oh sorry, 2 times, it's 2 times the focal length. In fact, we write it in the opposite manner. We write f is equal to r by 2. So we will see the establishment of this formula. Pretty easy, not that difficult. So we make our concave mirror. Okay. And we have our principal axis. This is my whole of the mirror, right? And this is my focus. And let's say this is the center of curvature. Fine, children? Okay, now just try to understand. From center of curvature, say I'm taking it with the H diagram. This is a radius. Do you agree? This is a radius. So if this is a radius, let me try to draw a tangent for this radius. This is the tangent for this radius. Okay. Now, once I have found this radius and the tangent, I have found the point of contact. And let me do my analysis with this point as my point of incidence. Okay, so I'll take an incident ray which is actually coming here. Fine. And obviously, let me take the incident ray parallel to the principal axis. Okay, so let's take an incident. Oh, so the incident ray is parallel to the principal axis, and this incident ray now should pass through the focus. Are we clear on this? Okay. Mathematics and laws of reflection now tells me that if this is the angle of incidence, then this is the angle of reflection. Both should be theta, right? And if you see this as a parallel line and this as the transversal, don't you think that this should also be theta? Just see, this is theta, alternate interior angles. Fine. You can write it on your own. I'm taking my time. Let's say this point is some point M, right? And from M, let me drop one perpendicular out here. I like this software. This gives very nice handwriting, but I just wish I would have got opened it up. So let's say this point is some point, say this point is some point D. Yeah, CMD. Clear, bacha? Now grade 9, exterior angle is equal to sum of two opposite interior angles. Then don't you think that this should be 2 theta, 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 2 theta? Anna, did you understand this? This is an exterior angle is equal to sum of two opposite interior angles. Now, this is a perpendicular drawn here. So I see that if you look at the right angles, okay, right angle triangle. If I look at my right angle triangle, I have got two right angles triangle. I have one right angle triangle which is CDM, triangle CDM, and I have one more right angle triangle which is triangle FDM. Dekho to children, CDM and FDM, right? In CDM, if I take the ratio of tan of theta is opposite side by adjacent side, right? Right. So how much is opposite side by adjacent side? It will be MD, right? And it will be CDM. It will be CD. MD by CD. Okay, right. Now here we have a small thing which you have to understand. For mirrors whose what you call the curvature is very, very large, the curvature is very, very large, at that time you won't see this much. Now this thing will come a lot, pay attention here. You won't see this much of a curvature. This part of the mirror will almost be linear. Have you understood? It will be linear, seedha rahega. Okay, I walk from my house to his house and she is watching me. How does she see me? She sees me walking in a straight line, but somebody from Uranus will see me walking along a curve. Don't you agree? So this portion, this is a very small happening which you have actually magnified a lot. So this MP is no more an arc, right? MP is almost a straight line or a straight segment. I can say it's a straight line or a straight segment. Have you understood? Right? For large mirror, that means D and P coincide, and MP is taken to be almost perpendicular to the principal axis. Is this logic understood? ये बहुत बड़ा करके आपको दिखाया है. It is actually a part of a straight line. D and P. So MP is supposed to be. So instead of this, now can I write tan of theta is equal to MD by CP? I can write that. Very good. Similarly, for FDM, what can I write? Tan of 2 theta is equal to similarly MD by what? FD. And instead of MD, by the same logic, I now write tan of 2 theta is equal to MD की जगह में क्या लिखेंगे बेटा? MP. divided by FP, right? Right. Now the second understanding that we have to develop here is that theta is very, very small. Theta is very, very small. And in such cases, in trigonometry also you'll study, sine theta is almost equal to theta, tan theta is almost equal to theta. So we will write tan theta is almost equal to theta, and tan of 2 theta is also almost equal to 2 theta. Right, children? So I write here theta is equal to MP. So I keep it MP. And what is CP? CP is nothing but the radius of curvature. Okay. And here I write 2 theta is equal to MP upon FP is what? The focal length. Arjun, all okay though, Baba? Okay. Don't hesitate, huh? Don't think that since you are not having maths, you should not ask. No, please ask. Now, if you take MP and C on this side, if you keep MP, then this side becomes what, beta? R theta. And this side becomes 2 theta F. Right? Theta cancels theta. So we say R is equal to 2F, which actually boils down to F is equal to R upon which you are trying to prove. देखो नहीं समझते हो तो Arjun, pay attention. If you think that there is anything you're missing, there is nothing to hesitate. Have you understood? We took tan theta is always tan is opposite by adjacent. So we took the tan ratio here. We took the tan ratio here. And we applied the first consideration that in this mirror, MP is almost to be a straight line. So if MP is a straight line, then D is actually merging with P. So instead of MD, I'm writing MP. Instead of MD, I'm writing MP, right? And rest is, if theta is very small, tan theta is almost equivalent to, theta. So tan theta. Neha, just give me the textbook once, as see one item here.
So can they ask questions like why is tan theta taking
चलिए next, shall we? Our next thing is the mirror formula, or the thin mirror formula, as we say here. Just check, we use the word thin mirror, right? I just missed it. This is called a thin lens formula. We have is the mirror formula. We don't use thin. It's just mirror formula. In lens, we say the thin lens. Okay, we come to what is known as the mirror formula. Now, if you remember all those that I taught in grade 10, mirror has an I, addition has an I. So in mirror formula, it is always addition. Lens has a E, negative has a E. So and what comes first? VIPs always come first in India. So it will be always 1 by V. So the mirror formula is 1 upon F is equal to 1 upon V plus 1 upon U. The lens formula is 1 upon F is equal to 1 upon V minus 1 upon U. Okay? So let's start this part now, and this will actually conclude your reflection part. Okay. So this is my pole of the mirror, focus of the mirror, and center of curvature of the mirror. Center of curvature of the mirror. I take an object which is beyond the center of curvature. Say the object is here. The object is here. Okay. So I go by my laws. A ray of light parallel to the principal axis, and then it passes through the focus. This is passing through the focus, and then there is another ray which is passing through the center of curvature in this manner, and this ray is going undeflected. So it's not that only 2 rays or 3 rays, that can be n number of rays through which this formation takes place. Okay. And again, put this point as point M. Okay. And I get my image is out here. So I start naming it now. This is AB, and here it is A dash B dash. Okay. Now whatever I'm going to write, just see. My first step will be consider right angled triangles. What are the 2 right angled triangles I'm looking at? Just look at me, okay? A dash, B dash, and F. A dash, B dash, and F. Okay. And similarly, I'm taking an triangle on that side to A dash. If I take it up, it will be M, and B dash means P, F. Okay. Now, this is a right angle triangle. By our analogy of last understanding, this is a straight line. So these are right angle triangles. And I will go by the ratio, this ratio, say object by this. So I take, say, A dash, B dash from this side, and I'm taking, say, A dash, B dash. So how to take this? Go by the nomenclature, A dash, B dash. So here it will be MP. Okay? This is equal to B dash F. B dash F. Look how the ratio is taken. A dash, B dash, so MP. B dash F, so we will take PF or FP. FP. Children, how to remember this derivation? Remember, FP is nothing but my focal length, and BF will be image distance minus focal length, है ना? आ जाओ, इसको भी देख लेते हैं. So here I am drawing a line. Say we have a line out here, right? And we have a line here. Sorry, we have a line here. So I have a measurement for this. I have a measurement for this, and I also have a measurement for this part. Right. So what are my measurements now? This will be measured as F, but negative F. This will be measured as negative V. Right? And this will be measured as V minus F overall, but as negative. Right? It's a V minus F, ना? V minus F, but a negative. ठीक है, ये वाला एक रेशियो मिल गया BF. So Instead of BF, I can straight away write BF को क्या लिखे बेटा? B dash P minus FP by FP. Clear? This much? Okay, I'm writing very big. I'm making them a little bit small. Else we won't be able to finish everything. This much, okay? Hope you are able to see. Now look at my second point would be consider triangles. Now look, the next triangle that I am considering, okay? You can take one more ray now. Okay. Consider triangle. Let's take one more ray. A ray which is incident here. Remember this? The fourth law. It will be reflected back with the same angle. And it also has to pass through this. Don't you agree? Yes. So I am taking, consider triangles, and these triangles are all, these are right angle triangles, and my right angle triangle are triangle ABP. ABP. Why did I take ABP? Because the object distance also has to be brought into the picture, na? Otherwise the object distance doesn't come into the picture. ऐसे ही याद रखने का, then your derivations become very easy. The object distance also has to come into the picture. So how does the object distance come into the picture once you consider this particular distance? So this is this would be my negative of u, right? And the other triangle that I'll take is this triangle, and you can take triangle versus triangle A dash, obviously B dash and P. This triangle A dash B dash P, right? So we will again play on this particular thing, okay? AB by MP. Okay, from here I am writing one more step on the previous one. Children, see, MP is same as AB. So this equation could have been written also as A dash B dash by AB is equal to B dash P minus FP divided by FP. This is your equation 1. Fine? Arjun, okay? And look here now, same ratio we will take. So you're between this triangle, so we will again take A dash B dash by AB. So you have taken A dash B dash by AB. Now, how we will correlate it? A dash B dash by AB. So on this side we will take B dash P, and on this side we will take BP. Equation number 2. A dash B dash, so AB. And on this side you took BP, so here. On this side B dash P, so P. Okay? So if you look at the two, then their LHS are same. So from 1 and 2, you get B dash P by BP is equal to B dash P minus FP by FP. ठीक है? अब इसको थोड़ा छोटा कर देता हूं because you have written all these things. Make this also small. And now let's put the values from this. B dash P. What is B dash P, children? Negative V divided by BP. What is VP? Negative U is equal to BP minus this FP. Or else you can do, if you want to go by this side, you take it BP. Okay, let's take BP by FP. What is BP by FP? What is B dash P? B dash P is negative V by negative F. Clear? Minus FP by FP, which is 1. Okay? Understood? Can this not be written as V upon U is equal to V by F minus 1? Same thing, right? Now divide everything by V. It becomes 1 upon U is equal to 1 upon F minus 1 upon V. I have divided everything by V, Arjun. So if I divide everything by V, what happens? A V comes here, a V comes here, a V comes here. And then what happens further? This V strikes out this strikes out this. And then you get your lovely little derivation to end the day, which is 1 upon F. 1 upon F is in this side. So this is equal to 1 upon V plus 1 upon U. Children, you might also say, sir, heavens don't fall if I say 1 upon U plus 1 upon V, but don't do that. Always say 1 upon V plus 1 upon U. This will help you in the lens. V stands for VIP, and India, it's VIP culture, so V comes first. This concludes the reflection part. I want you to properly at least do these two derivations when you go back home, so you're fine. And there are 2 or 3 questions in NCERT initially, okay? And I'll give you a couple of reflection questions also. There are 3 questions of NCERT which are exactly grade 10 questions, except the last question where it says it uses a convex mirror. In convex mirror, you just have to be very careful with these datas. In convex, the focal length is positive, the image is positive, however the object is negative. Okay, keep that. And it says the man is running at 5 meters per second speed. What is the image changeover after 1 second? Means in 1 second the object distance is reducing by 5 meters. That's the only thing you need to keep in mind and solve it. I think it was not hard today. It will start getting little bit ticked up from refraction onwards, but if you go stage by stage, read and come, there should not be any issue. I'll put some questions also from reflection so that you practice reflection part, right? There will be another reflection will come again when we study total internal reflection, but you just check some papers whether you're getting any question from this part. Righto?